All right, today we are going to start on section 5.3. Our objective is to divide polynomials by monomials and also to find monomial factors of polynomials. So this will build on our whole idea of GCF and also dividing out monomials. All right, for question 1, which of the following are not polynomials? Kian? B. I think B is a polynomial. How many terms does B have? 2. So if it's got 2 terms, that one is a polynomial. We're trying to figure out which ones are not polynomials. Natalie? D is not a polynomial. It's just got 1 term. So I agree. Any others that are not polynomials? Deshaun? A. A is also not a polynomial. It's just got 1 term. Those are both monomials. The only one we haven't addressed yet is letter C. Do we think that letter C has 1 term or more than 1 terms? Is it a polynomial or not? Kian? It is not a polynomial. There's just 1 term there. Remember, terms are separated by addition or subtraction signs. We don't have an addition or subtraction sign there. So even though it's written as a fraction, it's still just 1 term. All right, on number 2, which of the following are not polynomials? What do we think? How many terms do we have on A? 2. 2A and 6. We can't combine those. So that one is a polynomial. What about on letter B? How many terms? 2 terms again. They can't combine because we've got an x squared and a y squared. 2 different terms they can't combine. That is a polynomial. What about on letter C? How many terms? 2 again. 1 over x squared and 1 over x. Those are 2 different terms. They cannot be combined. And what about on letter D? 2 terms again. So all of those are polynomials. All are polynomials there. I'm going to run out of space. All right, 3 and 4, switch it up a little bit. On 3, we're trying to figure out what number belongs where that question mark is. So 1/8 plus how many eighths is the same as 1 plus 2 over 8. What number's missing where that question mark is? Natalie?
2.
A 2. When we add fractions, we add their numerators and keep the same denominator. So over on the right side, they told us they wanted to add 1 plus 2, so 2 is what was missing. Using that same idea, what belongs in my question marks on number 4? Need some new hands, or we're going to start pulling sticks already. May? 2 plus 4. Again, if we're just adding fractions together, we add their numerators, keep the same denominator. Of course, these were nice because they already had a common denominator. All right, on 5 and 6, we need to find the GCF. So we deal with the number part, and then we'll deal with the variable part. Okay, what's the biggest number, the greatest common factor that can divide into both 2 and 6? 2. If you're not sure about that, we could make the prime factorization list. What's 6 going to break into? 2 times 3. Okay, and then we're looking for matches from those lists, and we see that as far as numbers go, 2 is the only match. What else is part of my GCF? X. We also have an X on both lists. So my GCF is 2X. All right, to do number 6, I'm going to take away some of the stuff above it so I've got some room to show it. We already talked about that 6 would just break into 2 times 3. How many x's belong with that 2 times 3? 3 of them. X to the third is x times x times x. When I'm splitting up -4, what should I break it into? Not just a 2 times 2. -2 times 2. And then how many x's do I have on that one? 2 of them. X times x. What will 10 break into? 5 times 2. And then we just got 1 x on that one. So now when we're looking for a GCF of 3 different terms, we need it to match on all 3 lists at the same time. So what matches on all 3 of those lists? An x. What else? A 2, a positive 2. Okay, so a 2 is on all 3 lists, an x is on all 3 lists. Anything else? No, there's nothing else that's on all 3 lists at the same time. So my GCF again is a 2x. Even if something appears on 2 of the lists, if it doesn't appear on all 3 and we were given 3 terms, it's not going to work for us. Questions about any of our warm-ups? Okay. Then let's get into our notes. To divide a polynomial by a monomial, divide each term of the polynomial by the monomial and add the results. So we're just going to be taking these one term at a time. All right, so our first one is 5m plus 35 divided by 5. How many terms do we have in our polynomial on top? 2. So both of those terms, each of those terms is getting divided by what? By 5. So if you needed to write it out split up, you could write it as 5m over 5 plus, we're going to use that plus sign from the middle, 35 divided by 5. This is what it means when it says we divide each term of the polynomial and add them together. 5m over 5, how does that reduce or cancel out? Okay, we just end up with m. The 5's cancel each other out or reduce to 1, so we're left with m plus 35 divided by 5 is 7. Okay, pretty easy one to start us off. Questions about it? Okay, once you're starting to get more comfortable with these, I don't necessarily expect that you'll write it out split up. Just wanted you to see that that's what it meant from those directions in the previous slide. All right, on number 2, how many terms are in our polynomial? Two of them. We've got the 26uv and also the 39v. They're each going to get divided by the same denominator. So they're each getting divided by what? 13v. Don't leave off the variable part. All right, on this one we have to divide by a variable. It's a little different from last time. It's going to be similar to how we did these last week though. Okay, if we were to divide 26 by 13, what would we get? 2. What happens with the v's? Cancel out. So what else is left in the top? The u. We canceled out the v's, we still have a u. Plus, now we go down to the next term. 39 divided by 13 is 3. What happens with those v's? They cancel out. So we're left with 2u plus 3. Okay, the key to doing these problems well is to just take them one piece at a time. Questions before we continue? Okay. How many terms do we have in the numerator? Three of them. Remember, they get split up by the addition or subtraction signs. So we have 1, 2, 3. I'm going to use the same signs that they have. So a minus and then a plus. All right. What is going in my first numerator? First top. Jamaro, what do you think's going up there? X cubed y, good. What's going in my second top, Deshaun? So the top part in the middle. 4x, good. And my last top, Natalie? Good. What is going in all three of my denominators, Danielle? Very good. So in all three of these denominators, I've got an xy. All right, so now we just have to simplify. Now let's think back to last week. We talked about one of our rules of exponents. If we divide the same base, what do we do with the exponents? Subtract them. So I'm going to take 3 minus what? 1, and I end up with 2. So I have x to the second power. What happens to the y's here? Cancel out. Keep the same sign in between. All right, on the next term, what's going to cancel out? The x's. Is the 4 or the y going to move from where they are right now? No. So we still have a fraction, 4 over y. All right, on my last term, remember to drop that plus sign down. My last term, what cancels out? The y's cancel. Do the 6 or the x move? Nope, they got to stay where they were. So 6 over x. That's our final answer. Nothing else there can be simplified. Nothing there can be combined. Questions? Ready to keep going? All right, why don't you try the next couple on your own? If you're not sure what you're doing, split them up. Think about how many terms you've got. Give them all the same denominator and reduce what you can. On number 4, I split it up. Jakeem, what's going in the top for my first fraction? 16y. What about the top of my second one, Jerry-O? 12. What's going on the bottom of both of them, Deja? 2. Okay, these ones are a little bit simpler than the ones with variables everywhere. We just simplify the 16 divided by 2. What does that give us? 8. What stays with that 8? The y. If a variable doesn't cancel out, it stays with it. Just doesn't change. The minus sign comes down. 12 divided by 2 is 6. Questions? Ready for number 5? Okay, number 5 is a little more challenging. How many terms do we have in the numerator? 3 of them. Okay, so we got a term minus another term plus the last term. What's going in the top of my first term, Houston? 3x to the 4th. And in the middle, Keon, what do we have? Good. 9x cubed y. The last one, Tariana?
6x to the 2nd, y to the 2nd.
Good. 6x squared, y squared. And in the denominator of all of them, Kelby? Good. Negative 3x to the 2nd. All right. Now comes the fun part. We simplify one piece at a time. So one term at a time, one piece at a time. We start in the front. 3 divided by negative 3. Negative 1. Jay Sean, I think you might have been a little ahead of us. Then we go to our exponent on the x. If we're dividing the same base, what do we do with those exponents? Subtract them. 4 minus 2 is 2. So we have an x squared. Okay, for now I'm going to just drop that minus sign. It might have to change depending on the sign of my next term. 9 divided by negative 3 is negative 3. So now I'm showing that I'm subtracting negative 3. What could I change this into? A big addition sign. Questions about that? All right, then we move on to the x's of that term. X cubed over x squared. Just x. X to the first or just x. What happens with that y? Stays with it. It's not going anywhere. All right, on the last one. For now, I'll go ahead and drop that addition sign, but we might have to change it. If we take 6 divided by negative 3, what do we get? Negative 2. Now, if I'm adding a negative, what am I really doing? Subtracting. So I'm going to change mine to just be a big subtraction sign. If you leave it as adding a negative, that's not wrong. Okay, I just prefer to have one sign instead of 2. What happens with our x squareds? They cancel out. If it's exactly the same thing, top and bottom, they cancel out completely. And what else do we have with that minus 2? The y squared. I heard somebody say it. Can any of those be combined?
No.
Any like terms? No. So there it is. That's our final answer. Ready to go on to the back? Okay. All right, we say that one polynomial is evenly divisible or just divisible by another polynomial if the quotient is also a polynomial. To factor a polynomial, we must find the GCF of all the terms. Now, another important thing is that if we're saying it's evenly divisible, we're saying that it's got no fractions in the answer. No fractions in the answer. Okay. We don't want to have fractions in our answer on these if it's going to be evenly divisible. On the front side, we had some that had fractions, some that did not. Okay. So to factor a polynomial, we're going to find the GCF of all terms. So what can divide evenly into all of the terms? All right, so we need to find the GCF of this polynomial. We did this last week. Today we're just going to take it one step further and actually divide it out. Okay, so if we're looking for the GCF, we break these down. 16 can break into what, Jaquan? 4 times 4, and we know that 4s break into twos. Okay, so we've got 2 times 2 times 2 times 2 times y. That y belongs with the 16. We also need to break down the 12. So we break 12 down. What can 12 break into, Jalen? 4 and 3. And we already said 4 breaks into 2s. So we have 2 times 2 times 3. We need to look for our pairs or our matches. What matches? And more 2s. So our GCF is what? No. 4. 2 times 2 is 4. So our GCF is 4. We get a 2 from each match. Questions about our GCF? Okay. When we do these problems, when we factor out a GCF, we are then going to divide both terms by that GCF, by the 4. When we write our answer, the GCF goes on the outside of parentheses, and whatever we have left after we divide it out goes inside the parentheses. So 16y divided by 4 would leave me with what? A 4y. Minus 12 divided by 4 is 3. So the GCF is on the outside. What's left after we divide is on the inside. That's how we write our answers when we factor a GCF. Questions, concerns? Don't leave off the GCF on the outside. That's one of the biggest mistakes that students tend to make when we factor out a GCF. Even in my Algebra II class, students would leave that off. How do you think we could check ourselves? Multiply it back in. If we distribute the 4 back into the parentheses, we should end up with the original problem, which we would. Okay? Are we ready for another one? I'd want to know like what your GCF is. So you don't have to show your factor trees. If you know what the biggest thing that's going to divide into both of these right away is, you don't have to show your factor trees. That's fine. Does anybody know what the GCF of 4x and 20y is? 4. We can divide both of these by a 4. They don't have any letters in common. So here's what I would expect to see. I'd expect you to show me that you're going to divide both of those by 4. And then I would expect to see your GCF outside the parentheses and what's left over after you divide inside. So for our first term, 4x divided by 4, what's left? An x plus, we use that same sign from the middle, 20y divided by 4. 5y. All right, on this one, I bet most people could look at this and tell me at least part of my GCF. What's the number part of my GCF? 5. They both definitely can be divided by 5, but not anything bigger than 5. But 5 is not the only part of our GCF. If we were to write out the variable part, we would have 2 x's with the 5. The 10 would break into 2 times 5, and how many x's would be with the 2 times 5?
4.
Just 1. So we already knew without writing that out that we were going to have a match of 5s. But what else matches? We also have a match of x's. So our GCF is 5x. GCF is 5x, so that's what we're going to divide both of those by. If that's your GCF, that's also what gets written outside of those parentheses. And inside the parentheses, let's see what we would have. 5 divided by 5 is a 1. You can write the 1 if you want to. X squared divided by x is just an x. Drop that plus sign. 10 divided by 5. 2. X divided by x.
Oh, you cancel out.
They cancel out. So just a 1, which we don't have to write. They cancel out completely if they totally match each other. So I can shorten up that parentheses. That's my final answer. Questions about how this works? Finding our GCF of each of these and then dividing it out to show that we could factor it. All right. On this next one, it's going to take a little bit more work. I think we probably should show our prime factorization to show our GCF. So let's break down 28. Delaney, what could I break 28 into? Just 2 numbers that would multiply up to 28.
14 and 2.
Sure. All right, 2 is prime, but 14 can be factored more. Nevaeh, what could I break 14 into?
2 and 7.
Good. Okay, so I've got 2 times 2 times 7. How many A's would I have up there?
5.
5 of them. 1, 2, 3, 4, 5 of them. All right, then we move on to 12. We've already factored 12 today. Does anybody remember or look back and see the prime factorization of 12? Or do we need to make our tree again? 4 and 3 is not prime factorization. 2 times 2 times 3. And how many A's go with the 12? 3 of them. 1, 2, 3. Does anybody know the prime factorization of 20? 2 times 2 times 5. How many A's go with the 20? 2 of them. All right, what matches on all 3 lists? 2, what else? Another 2, and A and another A. Okay, so these things would all get multiplied together. So if I wanted to write my GCF off to the side, 2 times 2 is 4. A times A is A squared. My GCF is 4A squared. All right, that's what we are going to have to divide each term by. That is also what gets written outside of our parentheses. Inside the parentheses, we write whatever's left over after we divide. So 28 divided by 4. 7. You can also look up at your GCF lists up here that we've got. That will also tell you what's going to be left over. Notice that there's a 7 left over. What about when we take 5 minus 2? A to the third. Notice there are 3 A's left up there that we didn't circle. Minus, what's going to be left over in the middle? 3, what else? 3A. 12 divided by 4 is 3. A cubed divided by A squared is A. Plus, what's left over on the end? 5. Any A's? No, they canceled each other out completely. We used them both up when we found our GCF. That would be our answer after we factor. Questions about number 9? Okay. Let's do number 10. How many terms do we have here? 2 terms. Okay, let's talk about how we're going to figure out our GCF. We could do it by making both of our lists, but I think we might be able to come up with it without writing it all out. If you need to write it out, that's fine. If you need to write it out and circle your pairs, you can still do that. I think some of you might be ready to move past that. What's the biggest number that's going to divide into 15 and 20? 5. All right, then we look at our x's. If we were to write out our lists of x's, how many pairs or matches would we have for the x's? 2. So x to the second power. If we were to write out our lists of y's, how many pairs of y's would we come up with? Just 1. This one's only got 1 y. That's as many as it's going to contribute. How many pairs of z's would we have? Again, 1. So we want as many as we can possibly come up with pairs of. Questions about how we came up with that GCF? Again, if you need to write out x times x times x, and then below it x times x, and come up with your pairs, that's fine. Just trying to give you an alternative option for those of you that are ready for it. Now we're ready to factor it out. So our GCF, 5x squared yz, goes outside the parentheses. Whatever we have left over when we divide goes inside. 15 divided by 5. X cubed divided by x. Squared, sorry. X. Y squared divided by y. Z divided by z. Cancel out. All right. Drop that minus sign in the middle. 20 divided by 5. X squared divided by x squared. Cancels out. Y divided by y. Cancels out. Z squared divided by z is a z. Okay, these problems can look overwhelming, but if you take it literally one piece at a time and build your answer, it's not so bad. Just think about it as a bunch of little tiny problems all smushed into one bigger problem. Ready for the next one? I think we can fit in at least one more. Who can tell me the biggest number that will divide into both 8 and 12? 4. Okay, how many A's are part of my GCF? One of them. How many B's? 1. And how many C's? 2. Again, if you need to write out your variables expanded and circle your matches to figure that out, it's okay. This is just giving you a faster alternative if you can visualize the matches in your head. All right, our GCF 4ABC squared goes outside our parentheses. 8 divided by 4. How many A's do we have? How many B's? We don't got none. They canceled out. How many C's? They also canceled out. B's and C's canceled there. 12 divided by 4. How many A's? Canceled out. B's? C's? Canceled out. Okay, remember if they match completely, top and bottom, they cancel out completely. So that's it. Shorten up those parentheses. Questions about number 11? Go through and just come up with our GCFs on the next couple. Actually, let's do that tomorrow. We're going to save the rest of these for tomorrow. I'll click through to your homework. Even though we didn't do all the examples, you can still do your homework. It's the same process over and over. So we're on page 196, 2 through 20 evens, 22 through 38 evens. Why it doesn't just say 2 through 38 evens, I'm not sure. But remember, we do the written exercises.